Hi, welcome to the session on hydro and wind power plant. So, how the electrical energy is being produced using hydro or water and wind for the production of electricity. So, coming up with this, let us talk about the hydropower plant, where the classification of hydropower plant involves and types of turbine we come across in hydro, dam, and we talk about surge tank, water intakes, powerhouse, where the generator will be housed in the powerhouse, turbines again. Used for generation, then transformers where we need for stepping up transmission to the grid. So discharge of water supply, once it is being used to produce the electricity, the water is being discharged via the spillways and back to the reservoir, and how it works exactly. So hydropower plant can be classified as LMH, that is low, medium, high, head power plants. So low head is the water flow from a very low height to the turbine, and if you observe here, the medium head, the water is little bit at a height to the turbine, and the high reservoir, again the water height is at a very high level comparatively to these two. So the low, medium, and high head power plant is classified mainly on the the height of the water falling from the reservoir to the turbine. So low is classified when the water is falling from the height less than 60 meters, and medium head hydropower plant is considered when the water is falling from 60 to 300 meters, and a high head power plant when the height is greater than 300 meters to the turbine. So types of turbine runner, if you look at the water turbines are mainly used in hydropower plant, which can be classified as impulse and reaction. So impulse, we have Pelton type turbine and cross flow turbine, and under reaction type we have Kaplan, Francis, and kinetic types of water turbine. So this is how it looks, the hydropower plant Francis, turbine. This is called fixed pitch propeller and turgo, and this is the Pelton and very commonly used Pelton or Kaplan turbines, and this is the cross flow type of turbines what we normally use for hydropower plant. So coming up, how it works, the water is stored at a height from the turbine located at a particular height. So this water is stored behind the dam, where we have a channel for this water to flow from the water storage via the penstock, and the valve is produced, and the valve is here, which removes all the debris and unwanted things in the water, causing only the water to flow out of the valve, which hits the turbine blades, and this blade starts rotating, which is in turn connected to the rotor generator, and which is then electricity is produced. So if you see, the water hitting the turbine blade starts rotating, and it is connected to the turbine shaft of the generator. This is the turbine shaft of the generator, which in turn produces electricity, which is then stepped up to a particular voltage and given it to the grid. So we have a surge tank, to improve the flow of the water if we have less storage in the water storage tank. So this is how it looks. So the reservoir, we have a dam here, reservoir behind the dam, and we have a penstock, the intake, and control gates. The amount of water can be controlled here, and it can be left to flow in the penstock, which now hits the turbine blades, and in turn these turbines are connected to the shaft of the generator, which in turn connects to the generator, and it is then stepped up and given to the transmission lines. So this is the outflow. Once it hits the turbine, the water is now outflow, and it is collected again, given it to the reservoir. It can be pumped up and stored again to the reservoir. So that was all about the hydropower plant. Now coming to the wind power plant, we have a classification again with respect to wind power plant. We have types of turbine which is used in wind power plant, and we have a tower, gearbox, and brake, blade, pitch, rotor, nacelle, yam motor, powerhouse, anemometer, wind vane, transformers, and transmission. So let us see one by one how the classification based on the energy. We have unity scale wind, offshore wind, onshore wind, distributed or small wind. So these are the energies of wind we have, and using this energy, the first wind power plant was set up in Ratnagiri, Maharashtra. That was the onshore wind. In Oka in Gujarat and Tuticorin in Tamil Nadu in the year 1986. So India's largest wind power generation is at Muppandal Wind Farm, Tamil Nadu, Kanyakumari at a capacity of 1500 megawatt, followed by Jaisalmer Wind Park, Jaisalmer, Rajasthan at a capacity of 1064 megawatt. So these are the areas where we have wind power plants. So India is blessed with a coastal line of about 7,600 kilometer. So offshore wind we have. Now, based on turbine, we can have multiple blade type, propeller type, sail type, which results to horizontal axis turbine, and Darius type, Savonius type, which is a vertical axis turbine. Normally, we go with horizontal axis, that is the propeller type. So we have a hot, that is horizontal and vertical axis wind turbine. So this is the hot and H rotor, Savonius and Darius, different types of horizontal and vertical axis wind turbine. So horizontal is hot, vertical would be H rotor, Savonius and Darius. So coming up with the multi-blade type, this is how it looks: blade Dutch windmill and Savonius type and sail type. So we have propeller type. Normally we look, this kind of, wind blades, propeller blades, and we have various types also. So coming up to the wind power plant, the wind blades are, connected to the shaft of the generator. So as soon as we have, wind blades, we cannot directly give it to the generator rotor because the speed of this wind is not sufficient to generate the electricity. So we use we use a gearbox where the speed is improved, the speed of the this is improved and then given it to the shaft of the generator. So required speed is brought by, boosting the speed, required speed, and it is given to the generator, and it is then given to the, generator, where the electricity is now pulled via this pole down towards the ground level. And then we have a velocity sensor, at what velocity the wind is being produced, and minimum 14 kilometer per hour is required, the minimum wind speed. And if you look at, this is the shaft connected from whatever the generator this is rotating. And we have a yaw drive from the generator. It is collected towards the foundation level. This is the tower or control lots, from where the wind power output is given to the transformer to, step up to a required voltage, and then it is given it to the grid. So this is how it looks. This is the gearbox. This is the generator, rotor blades. To look at it as two blade, but actually it is three blade, designed at a particular tilting of the blades. So we have a power cables, tower, and transformers to step up and given it to the switchyard. And thank you for watching this video. And let us see the next topics in the next coming up sessions. Thank you.